All right. Good evening, everyone. We'll be getting off with the Web 2 talk in just a minute. Let's get going. So, it's been a little while. Welcome back from the break. Hope everyone had a good one. So we've been busy with a lot of other topics as of late. Things like reverse engineering, pwning, cryptography, steganography, all this weird stuff. But we haven't talked about web in a while. So we're going to kind of circle back and have a second look at that. So to begin, let's have a quick recap. So web includes both attacking web browsers and attacking internet-facing services. It's got a little overlap with pwn. You could kind of argue it has a little V in there too, but it is its own distinct category. And this comes up quite a bit in CTFs. You'll have both client and server-side attacks quite frequently. So a website's made up of a couple important bits. And if you've seen our previous talks, this should be pretty familiar. We have the actual content, which is typically HTML, or hypertext markup language. That's the kind of tree-structured thing that looks like XML, and people often call it code and debatable. You got your style, how the page is rendered. That's usually with cascading style sheets. Typically not too relevant for exploitation, although they can be useful as part of creating a phishing page, for example. If you've ever gotten a strange email that claims to be from RPI and then takes it to a bootleg-looking Roundcube site, the CSS wasn't quite with snuff. And then we have JavaScript, which is a convenient vector for exploitation and also a great way to add interactivity to a web page. Now, browsers need to pull all these resources in somehow, and they do so via the Hypertext Transfer Protocol, or HTTP for short. And if you just pop open your DevTools, you'll be able to see exactly what's going on. So, for example, if we load the INTROSEC website, this is what loads. You see, we ask for the website, we get redirected, we load it, we get some images, we get a style sheet, we get some fonts. That's pretty good. And as you can see, we only loaded about under a megabyte of resources. Keep that number in mind as we move on to other places on the internet, like CNN.com, which loads 6.5 megabytes of stuff, 21 megabytes of resources, half a thousand requests. It's the big deal. Don't look at Wikia sites. It gets really nasty real quick. You might notice that most of this website is ads, and ads correlate very strongly with terrifying network tabs. And as you can see here, there's all kinds of stuff flying in here. All these great tracking pixels, for example. It's always a mainstay. For, dozens of companies keeping an eye on what you're doing and where you're going. It's always enjoyable. But we're not going to look too much at what's going on outside of our computer for the moment. We're going to be focusing on the browser. This is probably a little more familiar than server-side stuff, and it's a lot more approachable. So we're going to go from the www to OW for the rest of the talk as we trip and fall down the stairs of weird web stuff. So web technology tends to be really generous with what it accepts. If your data looks, even remotely correct, it'll work. You forgot the head section, whatever. You have a block element inside the inline one. That's illegal, but whatever. Closing tags, you don't need them. So this can make websites that are pretty terribly made still work. And this is actually a necessity because if browsers didn't support all these terrible websites, people would ditch the browsers. They'd go find one that does work. So it's kind of a race to the bottom, and that has made making the web secure somewhat challenging because it also needs to be extremely reliable and very, very flexible. So, for example, here's the real basic form of exploitation you've probably heard of 1,000 times already. So HTML can contain JavaScript. You can just put it right in line. So you can just call mine bitcoins just right in the page. Now, separately, websites might let you provide input. So, for example, I could say my username is Dave, and the website will then say, "Thank you for your order, Dave." Or my username could be the joy emoji. And it would say, "Thank you for your order, joy emoji." Or my username could be script alert oops script, in which case the website would have an oops. So this has come up quite a few times before here. What we've done is we've conflated data and code, if we call HTML code for the sake of argument here. And this results in what we call cross-site scripting, or XSS, not CSS. They already took that for cascading style sheets. So, big problem here. Like, this means that any bozo can go onto my form and just start, running viruses on everyone's computers. And there's a couple vectors for this. We have what we call reflected XSS, which is non-persistent. So that means like someone sends me a evil link that when I open it causes the website to malfunction. So for example, it might say there might be like a field for this like custom header, and they could put some weird script in there that will just run it. There's also stored XSS, which is when it's persistent and it will keep showing up over and over again. So if my username has been changed to alert oops, that is persistent XSS. Every single person who loads the website and sees my name will get the script running. And so, for example, there was this great Twitter XSS way back in its early days, a tweet that would retweet itself. It was just a little script tag that would find the retweet button and hit it. And so it was a fantastic worm. It spread across the whole site. And that was persistent XSS. It was in the website itself. So it can be pretty devastating. It can create self-replicating worms, and it can do things like, mine Bitcoin or try to steal your credentials, all these kind of things. So we got to prevent this somehow. And there's different places we can do that. On the server side, we can try to filter and escape our input. So filters might say, look for people saying their username to be script alert 1 script and block that. Tell them, hey, you can't do that. You can't put a script tag in your username. You can also try to escape the input, which means you take the meaningful symbols and replace them with meaningless equivalents. So for example, if you could escape oops to produce this like ampersand left then semicolon thing, oops. And the browser will render that as a angle bracket, but it will not interpret it as HTML. And so that's that separation of code and data that's incredibly important to keep things safe. Now on the client side, we can do that kind of thing, but we can also actually, say this is text, not data, or not code. So if I say, I set the inner HTML of some element to be, a marquee tag, it will be flying across the page. But if I use inner text, it'll just be literally this text. So that's the kind of thing you're thinking about. If you're writing a client-side application, you should probably be using inner text. Because when you say inner HTML, you are saying, I am putting arbitrary content into this part of the page. It could be an image, it could be a video, it could be anything. Well, inner text is very specifically just text. Now, properly filtering data can get pretty difficult. Like, what if it gets unescaped at some point? Or what if we have 5 different systems at once that are all interpreting things differently? What if the filter doesn't understand that, this sarcastic cased script here is actually a meaningful tag? There's a lot of ways to try to get around filters and escaping. If you look up as like OWASP, XSS, filter circumvention, you'll find a gigantic list. Got all these weird things like, using the on mouse over event of an image, or, and tricking the filter by leaving this weird, like, and missing name, that kind of thing. You have things like building strings up from character codes instead of actually, putting them in directly. This has reminded me of some of the worst filters I've ever seen. They look for the word XSS as if that will protect them. It's kind of like, no, you can't come in here. You're called SSS, and the attacker changes it to something else and it works. So yeah, that's a fun read on its own right. So that's for attacking a website and then doing something bad on the website itself. That's fun. That's good. Now, oftentimes though, we want to do something on a website we can't control or that we can't own. So for example, I want to attack someone's bank, account and steal all their money, but the bank website doesn't have any obvious vectors. So what if instead we had our own website that would, when you load it, make your browser do some things you weren't expecting. And you might remember that browsers do their best to be, like make everything just work. They gotta just be compatible. They gotta not break. They gotta do everything right. So browsers might be a little too overzealous to do things for us. And that leads to cross-site request forgery, where a page tricks your browser into doing things that you weren't expecting, specifically to make use of, your credentials or some privileged access to do something. So let's say that Alice has an account with the worst bank in the world, dumbbank.biz, and their API includes this method, get/transfer, with arguments of who to send the money to and how much to send. This is already terrible. We should not be using get here. We'll talk about that why later. But it gets worse. So Alice's bank needs to have a way to actually log into it, so you can actually, prove who you are. If anyone could send anyone's money, it obviously would not work. So when you log into a website, it typically gives you a cookie, and a cookie is then sent along with every single request you make. So this lets the server know that it's Alice, but you kind of wonder, wait, why exactly do we need cookies? Couldn't we just remember who they are? And the important thing is that HTTP is stateless. So that means that every request is independent of every other request. There's no information that's persisted between things. Every single thing is totally separate. So that means that if Alice logs in, the bank would have no way of knowing it's her unless there's some extra information. And thus we use cookies. And so they're just bits of information that are stored on your machine and sent with every request to a server. And they're useful for things like keeping you logged in, as well as prompting this massive storm of cookie consent pop-ups that have infested the web. Thank you, EU. Troy Hunt has a great blog post talking about how annoying these things are. I would suggest reading it later. So, cookies have quite a few things to configure on them, and these have kind of crept in over time as the web has evolved and we've realized, oh, wait a second, this is a little bit insecure. So, for example, HTTP only means that JavaScript cannot see this cookie, which is quite useful if somebody is running malicious JavaScript. Secure means it will only be sent over HTTPS, or secure connections. Same site lets us kind of control who is allowed to get this cookie, and that'll come up later. And priority, which I actually forget what that one is. It's probably order. I should look that up. But there's a lot of stuff there, and not all of it is super relevant for us. And you can both view and modify these things in the developer tools. So this is, for example, the page for this presentation. We got all these cookies here, multiple websites, all these flags, all this kind of stuff. So each cookie has a domain it is associated with. And so in this case, all these are google.com cookies. If a site sets a cookie with its own domain, so if google.com sets a cookie for google.com, it's a first-party cookie. And otherwise, it's third-party. And this is where the whole notion of tracking cookies comes from, when one website sets a cookie that another website will later receive. And that will basically allow them to, track you at when, you go to one website, and then you go to Facebook, and suddenly Facebook knows you went to that website. So, back to the story here. So Bob wants to steal $20. And so Bob has his great website, evilbob.org or whatever, and it has this image on it. And notice this is not a normal image. This is not an image file. This isn't a JPEG, not a PNG, not a GIF, not a GIF, whatever you want to say. Instead, it is just a link that, if you went to that, would transfer $20 to Bob. So when Alice loads the page, her browser sees the image tag and tries to load the image. It performs a GET request. And because it is talking to a server, it's going to send cookies, which means that Alice has just sent this request to her bank with her authentication. So Alice is now out $20. So this has been a problem for a long time. Back in the old days, it was a classic joke would be to make a forum post where it would have an image in it that would log you out the moment you open the page. And that you might wonder, well, okay, what have we done since then? The answer is a lot. So first off, anything that causes state changes should be a post, because this should be, get just means I want to load some data, but it specifically does not mean I want to change something. That's what like post, put, delete, those kind of things are for. All those HTTP verbs you probably forgot about. And this makes it a little hard to do this. Like an image tag will not execute a post. Now, malicious JavaScript can run a post, but at least this way, form threads aren't going to get you. Now, we mentioned that cookies have some flags on them. And most importantly is that same site one. So modern browsers like Chrome and Firefox, and this is a pretty recent change. Like your dev tools were complaining about this for a whole year, but they finally did it. Cookies are not sent cross-origin unless they're both secure and they have same site explicitly turned off, which confusingly means it's it's always possible to go between sites. And then there's other options here too. We don't really care too much, but basically it means that it will only send the cookie if we're already on the bank website, which is a lot smarter, as you can imagine. It just says on the side here, a cross-origin request is when you go from one domain to the other. So if evilbobsite.org requests something from dumbbank.biz, that's third party. That's cross-origin. And this is kind of governed by something called CORS, cross-origin resource sharing, which you've probably heard of as you were Googling fix CORS error 2020. It mostly comes up as, this broke my website, how do I fix it? And this basically controls where you're actually allowed to load stuff from. So typically a website will not just give pages to anyone else. Now, the ultimate weapon to preventing this is the CSRF token. So what happens is the server will generate a random token and embed it in the page. So like they'll put it as a hidden input form, value, and it'll have some long, almost impossible to guess value. And then the server, when it receives the form submission, send $20, it will check if you actually included that. And this completely defangs the attack. Bob cannot get the CSRF token, so he cannot make a valid request. He does not get $20. Now you might wonder, wait, hold on. Can't Bob just ask for the page? Because he can make requests, right? And he could load images. It's like, we know that a website can load images and do stuff with them. So CORS prevents this. And again, it says who is allowed to actually load data from the site. So malicious JavaScript cannot see the bank's send money page if Bob asks for it. It'll just get an error. And you see here, I try to load something from example.com, and nope, doesn't work. Now, unfortunately, lazy programmers may go into Stack Overflow and see, oh, I can just set this header, access control allow origin star. Now every website can load data from me. That's great. And they have completely defeated CORS, ruined everything, and it's totally useless now. So, watch out for that. Now, another aside, you might think, hang on a second, this is client side, isn't it? One thing we talked about pretty frequently here is that you can't trust the client. The client is, controlled by the attacker. The client can do whatever they want. They could say, hello, I have $11 million, and if the server believes that, then they're in trouble. So, couldn't a malicious browser just lie about where it's coming from? That's just one of the headers. You just change it. It's not illegal. Probably. But the thing here is that we are protecting users from malicious web pages. The browser itself is acting correctly. It hasn't been pwned. It hasn't been hijacked. What's happening is that the browser is doing stuff that the user probably didn't actually want. It's being abused. So the browser itself is still secure. It's not sometimes it does get pwned, and then you're really in trouble when you escape the sandbox and break out and get kernel, get root and oh dear. But we're talking about just websites being evil. So it's fine here because the web browser is able to protect itself and able to make decisions to kind of protect its user. And when you think about it, web browsers are kind of frightening. They will load and run stuff from just random people on the internet. And they need to just work. They got to keep loading these web pages. They can't just, with this whole same site thing back here, you couldn't just drop this in and say, oh, you have to have this now. There you go. Because then a lot of stuff would break. So there's a lot of this kind of technical momentum and not technical debt to an extent, but really just this kind of baked-in systems that have to keep working. And on top of that, browsers are an entire operating system. Chrome is trying to do some crazy stuff with web USB, but beyond that, they do video and audio, images, they do file, they do everything. So and then finally Google. So all these things together, it makes it kind of startling that it's safe in the first place. So browsers have a lot of mitigations against websites being evil. You might remember hearing about like Spectre and Meltdown a couple of years ago, and for that reason, browsers have random jitter and time measurements to prevent such timing attacks from happening. Firefox will lie about your time zone, your fonts, your window size, all these kind of things to prevent fingerprinting. Because if you gather enough of these unique data points, you could identify someone without ever giving him a cookie. And things, Chrome will notice signs of obvious XSS and actually just, block the page in the first place. So browsers do a lot of work to keep you safe, and they're massively complicated pieces of software. It's very cool and also very frightening. A lot of interesting security research to do in that area. So this is a little kind of cliffhanger for y'all. We talked about CSRF, client-side request forgery. But it kind of makes sense. Well, what about server-side request forgery? And this gets pretty fun. It's a great way to kind of pivot into a vulnerable system to get at internal systems. So for example, if you manage to get a website to load an arbitrary URL, you can start poking around its intranet and seeing what's going on in there. So we're going to talk about this some more on Friday. So to recap briefly, the web is great. The web sucks. It is both of these things at the same time, and that's what makes it so interesting. There's a lot, a massive amount of work that's gone into making web browsers both flexible and powerful and secure. And we've been kind of tripping over some of our older decisions in recent years as we discover maybe things shouldn't be quite so open as they first were. So, thank you all for coming. And drop by on Friday for some more web hijinks. We'll be talking about a bit more advanced concepts, probably talking about server-side attacks, maybe some filter evasion, all that kind of fun stuff. And as always, I invite you to join us in Slack. You go to the URL there, slack.rps.ec. That is the wrong address. I had to fix that. It is rpasec.slack.com is what you want. I will fix that in a moment. But you go there and you can just make an account with your RPA email and join us. So yeah, hope to see y'all on there, and thank you for coming.